Okay, welcome back. So, today we will be covering web security and some program security as well. So, before we begin, I will start out with some background of the web, some things which you should be aware of, and then we will again, much like before, get into the attacks against web as well as defenses against them. So, with that background, let us get started. Today I am going to use slides with, I will write on the slides itself. So, all of us use internet extensively and it is a very popular application. So, basically 1989 this Tim Berners-Lee's started out with the blueprint for the web, and slowly things started improving. At the beginning it was not a graphical user interface, it was a text based interface. So, 93 was when the browser was released, and then a consortium was formed to develop the standards, which means what standard should web adopt. So, that is how things evolved. So, these are all terminology which you are probably aware of. I am just going to reiterate some of this. So, basically what is a web application is nothing but someone has put up a bunch of web pages out there. Through the browser you can access these web pages. Okay. Now, what is a web page? This is made up of something called a HTML file, which is what we call as a base file, and within this HTML file you can embed many other things. So, from this HTML file you could go to other HTML files, you could view images on that particular HTML file, there could be Java applets, audio files. So, basically it is a document where you have embedded lot of different elements which you can access. So, that is what a web page is. And whenever there is a text or an image that takes you to another page, we call it a hyperlink. Okay. And this, when you move your cursor, it shows you that this is a hyperlink. Then when you click on it, it takes you elsewhere. So, whenever you type something on a browser, what you type is called a URL, and this is the structure of a URL. This is also something you are familiar with, but probably what there is a structure to it, maybe that structure is not quite in your head, but the first one basically tells what is the protocol. So, HTTP is the protocol it says you want to use. Sometimes you will see HTTPS. If you are using file transfer, you may also see FTP : //. So, this essentially is a protocol aspect of it. After that comes the host name. Again, people get confused. There are terminologies here, we call it domain. So, for example, in this specific case, IITB.ac.in is a domain that is belonging to IITB. Within this domain, there are multiple machines or computers, okay? And computers can be given names. Like for example, some computer within IIT Bombay has been named www.iitb.ac.in. That is the name of the computer, it is a host name. Okay. The reason www is often added is if that computer is hosting a web server, we tend to represent web servers with www. But it could be some other computer where you may not use www. For example, I could access a host name with let us say obelix.itb.ac.in. Okay. So, that is the name I gave to my computer, then I can access it. There I do not add www. www is typically means that computer has a web server within it. So, this is the host name. Within that computer or the machine, it could be a server, it could be a desktop, whatever it is, you are now going to put certain images or other HTML files or whatever it is. These are all the resources. So, you want to specify the path. So, typically wherever that web server, there is a base, there is a root directory. Relative to that, you are now saying within that main folder under images, under header, there is this image called IITB logo.gif, fetch that for me. That is what the URL is saying. Okay. So, that is the jargon here. This is also something you are aware of. when you are seeing these web pages, you see lot of nice fancy stuff. Some text is bold, certain paragraphs are there, then there is some image, then you may have italicized text. So, there is a lot of in display of the text, you want to specify how things should be. So, for that basically two things help. CSS is also, I will come to it, but basically all this is written in hypertext markup language, which basically tells how that document should be displayed. And that things that go along with it are CSS, XML, XSL. So, I will focus only on CSS, the others are not as important. And these web pages, because they have a markup which basically says this should be bold, this should display like this, here an image should come. This interpretation of the markup the browsers do, which is the programs that know how to interpret this HTML. And we have a variety of browsers, Internet Explorer, Google Chrome, Firefox and so on. So, this is so far what we have seen, HTML, CSS, all those are documents basically. But there is a protocol associated with web, that protocol is HTTP. So, this basically tells how should a client interact with the server. So, you may have already realized that web is a client server model. So, client is often the browser that is trying to establish a connection to the server. Okay. So, this browser that is running, so this is the client and this is the server, and this client will initiate the connection again using TCP, because we want reliability as part of it, and as part of it sends some request. In response to the request, the server is going to respond with some document. That document is written in HTML, it is one example of it, but this request response is a protocol. So, people often confuse HTTP with HTML, both are very different. HTML is a document, HTTP is a protocol that tells how can a client interact with the server. And oftentimes when it responds, it includes certain codes within this, this also we will see shortly. So, as I mentioned, this protocol operates over TCP, and if you are using HTTP, that is what I have written, the server port will be port 80, that is the server is listening on port 80 for incoming connections from the client. In fact, there is also HTTP 3 now, which has come up in fact quite some time back, but to start out with, they started with version 1, then they upgraded it to version 1.1. There was HTTP 2 also, and now there is HTTP 3. So, it has evolved, and another thing to note about, much like other protocols we talked about, is HTTP is also a stateless protocol. Like ARP also we mentioned is stateless. Stateless means this server, when it is interacting with this protocol or with the client, it does not remember what has happened in the past. It will only act on, this is the request that came, what is the request telling me, and in response to the request it will just reply. It will not keep state on, in the past I have received these requests, thereby these mean something, it does not keep track of that. This again I will get into a little bit detail when I cover cookies. Let us skip this, I do not think let us not worry about, so let us not worry about an older version of HTTP, let us focus on the later versions. In fact, 2, 3 also follow the same thing, so let us just focus on this. Oftentimes when you use HTTP, we use what are called persistent connections. Persistent means that once you open a connection, so this is let us say a client and this is the server. So, there is a three-way handshake, that is the SYNAC. After this, the data transfer is going to happen, and through this you are asking some request to the server, and that will send a reply. Okay. In the past, once you send a request reply, you close the connection, which means again you have to do three-way handshake. That is going to add lot more delay. So, here what you do is, after you do the three-way handshake, you keep the connection open, and you can send as many requests as you want, and replies can keep coming. So, this is going to reduce the overhead. Okay. So, that is what we call as persistent connections. Within persistent itself, there are 2 modes. I don't know. Okay, so let me tell again. So one we saw is persistent connections, where ignore all this, just focus on what I am drawing. So this is the three-way handshake, and as I mentioned, persistent means don't close the connection after you send a request and response. Okay. What pipelined means is you could potentially send multiple requests all at the same time. So same TCP connection, you are now going to send multiple requests to the server. So that is the it is persistent, and not just that pipeline means you are sending multiple requests in one go. In other words, you are not waiting, send a request, get a reply, only then send the next request. That is not what you are doing. Here you are able to send multiple requests in one go. Okay. So that is the background with respect to the web. Now I will get into the web server attacks and client attacks. I will have to change the slides. Okay. So with that background, let us now focus on what security issues the web application faces. So here, as I mentioned, there is a client server architecture. We will start out with client side attacks. What that means is that these attacks are going to affect the clients, and then we will also cover server side attacks. That means you are launching the attack on a server. Okay. So that difference will become obvious as we go further. So the CIA you are going to see everywhere. We have seen confidentiality, integrity, availability earlier. The same goals apply even when we cover web security. So basically the meanings here will be slightly different. So for example, when we talk about confidentiality, you don't want, as you are browsing the web, your computer has certain information, you don't want some malicious, suppose you accidentally happen to land on a malicious website, you don't want that malicious website to gather some information that is sitting on your computer. Okay. So that will be a violation of confidentiality. Similarly, you don't want any content that is on your computer to be altered just because you are browsing. In the process of browsing, things should not get altered on your computer. Similarly, an aspect of integrity is you should not download malware also onto your computer. Okay. Privacy is another goal that comes specifically in the context of web, is that you cannot spy on me or my activities online. In other words, I visited this website, after this I visited some other website, and then after it I visited some other website. Someone shouldn't know that this is my browsing pattern. This is also not allowed. So these are some of the security goals that are there with respect to web security. Now this web security, so when people started, they did pay some attention to security aspects. So when web itself was built, there are basically two defense mechanisms that are inherent in web browsing. Of course, in spite of these mechanisms, there are still attacks. That is what we are going to cover. But first, let us see what are the inherent mechanisms that are already there. So one defense mechanism is what is called sandboxing. Okay. So if you see the web browser, if I open Google Chrome or Firefox, these web browsers basically run in a sandbox. Sandbox means that whenever they are running, they cannot alter other files outside of the sandbox. So when we talk about a sandbox, this sandbox environment will give you access to certain folder structures, which is the path it will specify, and you can only access the files within that path. You cannot go and access files that are outside the path. Okay, that it will not permit. Similarly, when it is executing certain things here, the kind of memory allocation, whatever, is also decided by the sandbox. You can't run into infinite loop, then it will stop the program and things like that. So that is what general sandboxing means. Sandboxing is basically ensures that one program cannot affect some other programs. Both the data as well as alter its behavior. So that is what it is. So it just gives you enough permissions to run. So, the browser itself will run in a sandbox, not just that whenever you open extra tabs, each tab itself will run in a separate sandbox. That means, whatever is happening in one tab cannot affect whatever is happening in the other tab. So, that level of isolation also it provides. So, when you are in a tab, you are, for example, as you will see, there is some JavaScript and other stuff. So, when you are doing this JavaScript, it will access certain things, it will execute certain things, but that execution of a given tab cannot affect some other tabs files or cookies or anything like that. So, that is one specific thing. So, this ensures that bugs in a browser have very limited damage. So, that is one aspect of security which is through sandboxing. The second aspect of security is through something called same origin policy. Again, this is a very important aspect of web security where you do not want. So, you first let us define what is an origin and then what does same origin policy mean. Origin is basically decided by this thing, that protocol, host name, port, these three combined specify a specific origin. And what same origin policy says, that one origin cannot access resources of another origin. So, for example, if there is a JavaScript that is running for a given origin, it cannot access the cookies of some other origin, for example. Okay? So, or files of some other origin. So, this is something which is, again we will see when we look at some attacks, that even with this in place you still can launch those attacks. So, that is the basic idea. So, here let me ask a few questions. Suppose you have is this the same origin as this? No. Why? The protocol has changed. So, that is also something to keep in mind. The fact that you have used HTTPS does not mean you can access documents of HTTP. In fact, that is because the protocol has changed, it will not let you accept. Okay? So, that is the idea there. So, here is, for example, so here this is asking for A, this is asking for B, but they are the same origin. So, you can, for example, when you are doing this, if you want to access B, you can potentially access. Whereas here you may think they are the same, but the host names are not the same. There is a www in one case, whereas the other does not have www. So, because the host names are not the same, again it is not same origin. Similarly, here the protocol is different and here the ports are different, even though it is the same host name. Okay. So, all these are very important when you are doing web browsing, where the basic idea of same origin is the ones that belong to the same origin can access same resources, but anything that is outside you cannot access other guys' resources. So, that is something to keep in mind. So, one of the first attacks which I think is similar to the TCP session hijacking attack, I will just give a little, I will spend very little time on this, is that you can take over a HTTP session. So, let us first talk about what a session ID is, and then I will talk about what does taking over a session mean. So, for this I need to talk a little bit about cookies. So, let me talk about cookies first. HTTP, as I mentioned, is a stateless protocol. Okay. What stateless means? It does not remember what has happened in the past. But you must have seen when you are doing web browsing, for example, Amazon, you are shopping, right, you are adding things in the cart. So, you added one item, you added second item, you added third item. Okay. Now, you want to do some payment. So, there is a request that says you want to pay for something, but as I said, because the protocol is stateless, that is how it was designed, unfortunately. It does not remember what has happened, it does not know you added item 1, you added item 2, you added item 3 in the past, because it does not remember, it does not keep track of the state. Okay. But then when you make a payment request, you need to know what is in your cart. So, the general HTTP whatever protocol does not remember. So, people had to come up with some other ways to manage this, and that some other way, in fact, you do not even know who this user is per se itself. So, that some other way is through the form of a cookie. So, what basically happens is when you first contact the server for the first time, it will create a cookie, and within this cookie it is going to save your information. Okay? It will say your name is so and so. If there is any other things it wants to associate with you, it will associate everything with it, and it will basically tell that this name is associated with some cookie. So, there are attributes to this, so it will do that mapping, and this cookie the server will pass to the client. Okay? And what the client does is any time it is contacting the server, any request it says, it will pass the cookie to the server, and the cookie has information about you. So, what the server does is it may have a database where it may say, okay, you have put item 1, you have put item 2, all this is associated with some cookie ID. So, whoever is this cookie person, so it may say cookie, this person has a name and these are the items in his cart, all this is in the database. But that cookie ID is passed to the client, and each time the client contacts the server, it will send what this ID is. Based on this ID, you will access the database and know the current state of that particular user, that he has put these many items, this is his name, this is his billing address, this is his credit card information, whatever it is, you associate with that particular ID. And this ID, the client has to keep sending for every request. In fact, you do not, I mean the browser does it for you, you do not explicitly do. The browser knows that when you are accessing Amazon.com, this is the cookie associated with Amazon.com, and automatically it will start sending the cookie. Okay? That is how the stateless protocol is handled by using cookies for maintaining state. Now, when we talk about cookies, there are two types of cookies here. One is called persistent cookie and another is called non-persistent cookie. As the name implies, persistent cookies means these cookies stay on your machine for a long time. Even if the TCP connection ended, the session ended, you closed the browser, you went away, you came back, again reopened the browser, revisited that website, the cookie will still stay. It will have a lifetime of few months or even years. Okay, these are called persistent cookies. So, certain information which like your name or any other information will be saved in a persistent cookie. There is also something called non-persistent cookie, where when you open a session that you are browsing, it will again create a non-persistent cookie, it will save it, but the moment the session ends, that cookie is destroyed. It will not persist beyond how many 1 hour you browse, that will stay only for 1 hour. The moment you close the browser or you close the tab, that session cookie is closing. It's actually, there are variants here, but finally the thing is it's not going to last for very long. And this also, when you set this non-persistent cookie, is often called the session ID. So, when you establish a session, it will give you some random number, and for example, the reason why this is there is first time when you contact the server, you will give your username and password. Okay? Because HTTP is again a stateless protocol, it does not remember whether you are logged in or not, whether you are a valid user, whether you authenticated correctly, all that it does not remember. Okay? That is why when you first time you contact the server, it will create the session ID only if yours is a successful login, and that session ID is passed to the client. And next time you request something, that session ID is conveyed back, and that session ID, it will check, is this a valid session ID? That will tell you that yes, this is a user who has authenticated in the past. That is when you serve that request. So, if the session ID that you send to the server is an old session ID which is not in the list of active session IDs, it will drop your request. But if you have successfully logged in the past, this session ID that you send, the server knows that this is a valid session ID, and thereby it will honor your request. Okay? So, session IDs are this non-persistent cookies, whereas persistent cookies, both whatever, like when you contact a server, it can put 10 cookies in your client. Some will be persistent, some will be non-persistent. Whenever you contact, all of them you send to the server, and the server will accordingly act. So, that is the context of session ID. This is clear to everyone what a session ID is? Yeah.
Cookies are with the client or with the...
Always with the client.
So, if I log in on Amazon, I add something in my cart, then I log out and then clear the browsing history, and then still when I log in to the Amazon and sign in the cart my products are there.
Yeah, that is because that what is happening there is that there is a database. The database will have certain ID, against the ID it will have all this item 1, item 2, item 3 and so on. This ID is in your cookie.
But I cleared the browsing history, so the cookie...
Browsing history clearing does not mean the cookie is cleared. You have to explicitly clear the cookie. History is different from cookie. Cookie also you can clear from the browser, but browsing history is not the same as clearing the cookie. Okay, so it is there like cookie, when you pass that ID is in the cookie, from that ID it will extract these are the items. Okay, so this is with respect to the session ID. Session ID, just reiterating, is a non-persistent cookie which is valid only for that particular session. Okay. Now, the idea is that the attack is where you want to take over. So, there is some A, B and they are talking with each other, and as part of it some session ID has been established with A. It authenticated whatever. So, for example, there is a server, A authenticated with the server, it got a session ID which it is saving in its computer, and each time it talks with the server it will pass it. Now, you do not want to log in because you do not have the login, but you want to pretend to be A, so that once the login has happened then you will act as A and gather some resources from the server. Now, how can you do this? That is where session hijacking comes. If somehow you are able to steal the session ID and then in your request, so Mallory is now using Alice's session ID and contacting the server. Now, the server, what does it care? It just sees is there a valid session ID, it will associate it with Alice, and Mallory, if it is able to pass the session ID to the server, server will think Mallory is Alice and pass on whatever information related to Alice to Mallory now. Okay, or let Mallory do whatever actions Alice is permitted on the website. So, these are all dangerous things. So, the idea here is that how do you do this? If you are on path, things are very straightforward. You can look at the session ID when you are doing this HTTP transfer. Okay. On path means you are able to see all the traffic A is sending to the server. Then in which case if you are able to see the traffic, you can look into the session ID, steal it and then use that session ID to contact the server. So, here are some defenses against this. You want a random session ID or you encrypt the session tokens. So, this is also, so when you are setting the cookie, you could for example use the secure flag, which basically mentions that any time you are passing. So, when I say encrypt session tokens, I am not talking about encryption on the client. I am talking about when these cookies are going over the air. It is saying use HTTPS. In other words, while you browse the usual traffic, HTML, CSS, whatever it is that you are downloading, that need not be encrypted, that you could generally browse. But the moment you are passing any of these session information like cookies, persistent or non-persistent does not matter, you should always use HTTPS for it. The moment you use HTTPS, even if you are on path, you cannot get that information because it is encrypted. Okay, so that is the basic idea here. So, there is for example, when you are setting cookies, the server can say all cookies need to have security flag enabled. What the server is telling is telling the client is, whenever you send me cookie information, you cannot send over HTTP, you have to send over HTTPS. That is what the server is telling the client. So, that is the secure flag. This aspect of HTTP only, again as I mentioned, there are JavaScripts that run. So, for example, lot of things browsers do, this sending the cookie to the server, you are not explicitly selecting something, the browser is automatically doing. How is the browser automatically doing? I mean, it knows to do it, but apart from that, there is often JavaScript that runs which can also access the cookies provided it is the same origin. If it is the same origin, it will access the cookies corresponding to that, and with that cookies the JavaScript can also do certain executions. So, here what it is saying is that scripts cannot access these session IDs. So, it is basically saying even though this JavaScript has come from genuine website. So, for example, what I am meaning is, suppose you are visiting www.iitb.ac.in, okay, and this has some JavaScript within this, and let us say there is a cookie associated with this particular website itself, same origin. When I am telling this, this is saying even though this JavaScript I downloaded from iitb.ac.in, this JavaScript can still not access the cookie information. This will become clear when we look at some of the other complicated attacks, why this is disabled. Okay. So, you could for example use this HTTP only to prevent that as well. Okay. So, this is all ways to protect session hijacking, where cookie information is very important, the session ID is very important, and you have all these mechanisms to stop it. So, that is the idea there. Persistent cookies are not they are not continuously updated, but session ID will anyway change. For every session you will get a new cookie in some sense.
So, whatever I browse on Amazon, it would be saved in my cookie?
No, no, no. Whatever is happening, the server will maintain its own state. It will associate with an ID, that all that state will be associated with the ID. That ID is saved in the cookie, which you are passing it back. That way it will recover what you did based on the ID. So, the second attack is what is called phishing attack. This is something where lot of times the vulnerabilities happen mainly because of this. You will get some email saying click on this link to reset your password has been stolen, click on this to whatever set your new password. Lot of those type of emails are examples of phishing. So, you have to be extremely careful when you deal with these type of phishing emails. Okay. The idea with phishing is that you are first, there are two things happening. One is through some means, be it email or website clicks, okay, you are forcing some user to land on some malicious website which looks identical to some trusted website. Okay. So, for example, IITB, you trust IITB's website, but through some email it will have some way of covering it up, but you will see at www.iit. So, for example, something like this will be there. So, you are showing this bank.com on a website where you actually are seeing that it is saying bank.com, but the moment you click on blank.com, the reference for that is attacker.com. Okay, so, when you look at it, you think you are clicking on bank.com, but actually it is going to land on attacker.com, and attacker.com may have an identical website as bank.com where you cannot distinguish, and then you think you are on bank.com and you may enter your username and password, and then your password is compromised. Okay, but these type of attacks, so especially with this hyperlink as I have mentioned, what happens is when you click on this on the browser against the URL, you will actually see attacker.com still. Only if you do not pay attention to that part, you will enter your bank information. But these type of redirections as I am talking about are visible to the user, because you will actually see, even though you saw bank.com, you clicked on it, if it redirected you on the browser URL field, you will actually see attacker.com. So, that is why whenever you browse, you should pay attention to where you are landing, that URL you have to pay close attention to. And if you see attacker.com there, but the website looks identical to bank.com, you know something fishy is happening, you should not enter any information. So, to circumvent some of these, as you can see here, can you see the difference between this and this? People can see the difference. What is the difference? W became VV. Okay, so you could, for example, so you could do this type of, you will register that VV Eastern Bank against Western Bank, and you will do this kind of where even when you look at the URL, you may not be able to distinguish because W looks very similar to V. Okay. Similarly, this in fact was a attack that was launched against PayPal. PayPal is again lot of money is involved. So, what people have done is this P character in Unicode, it has this value, but there is some Cyrillic P which has a different value. Basically it's referring to a different domain basically, and people have, and the browser when it displays on the URL, you can't distinguish between the Cyrillic P and the regular P. So, you actually think you are landing on PayPal, but you are actually landing on some other website because the P has been encoded differently. Okay, so, this is called a homograph attack, where you use international characters, but these all of late the browsers will warn you if there is some such thing, the browser will tell that you are this is not the regular P. Okay, so, the main defense against these is that whenever you do this clicking on somewhere, especially do not click anything that comes through email unless you absolutely trust it, and whenever you click something, you should always pay attention to what the URL is on the top, which is the browser's URL, and some non-ASCII characters the browsers will help, and oftentimes the browsers also maintain a list of such phishing sites and will warn you. So, you must have seen sometimes when you browse, it will say this site appears suspicious, go away, some such browser itself will warn you. So, this is the way you are going to handle these type of attacks. The next client side attack is what is called clickjacking. So, clickjacking is basically tricking the user into doing something which will be beneficial for the attacker. So, for example, yeah, so let us look at this. This is an example of clickjacking. So, what you are doing here is you are going to, so this is kind of showing you what is happening, but you won't actually see that like button behind. What you will actually see is something called claim your free iPad. Okay? Then what you do is, you, because it is all very exciting, you will click on that particular thing. But when you click on it, what actually is happening behind is you are liking some Facebook post. Okay, so basically the idea is that, you know, the Facebook, social media, whatever, the more likes, the more follows, more whatever you have certain advantage with respect to monetarily, maybe you will get advertising more and things like that. So, people want more people to like your posts, like your comments and so on. So, this was one way in which people now started to hike up all your likes. So, basically there will be a malicious website which will do like this, people will just click on that, and when they click on it, someone's post somewhere is getting a like. Okay. So, that is the example of what is called clickjacking, where in the website you will put something that is attractive, but the action that happens behind it is something which is kind of different. Okay. So, you have to be mindful of these as well. Cursor jacking is another similar thing which this place, I will share these slides with you, you can check out this website. So, the idea there in cursor jacking is, so there is one whatever, this is some cursor, something they show, and maybe this is the hand that is somewhere there, and they use JavaScript to show an artificial cursor on the screen. Okay. and when you move this artificial cursor, you think you are going somewhere else, but the real cursor is going somewhere else. So, they will have something like here, they will say okay, click whatever for your price, but when you click on it, somewhere else is where you are clicking. So, it gives you a wrong impression that. So, through JavaScript, they are displaying an artificial cursor while they are controlling the main cursor. So, if you look at this website, it will become clear as to what is happening there. So, that is example of cursor jacking.